Hi everybody, so we'll complete chapter 11, and this is it should be a small section. It's not something extensive. Sometimes it's being skipped and sometimes it's covered, but the engineering folks need it, and we should talk about it. And also we talked about e to the power x function, that when it occurs, sometimes it occurs multiple times, and you have to either factor it or simplify or cancel it. So yeah, so you'll see here that some of these even and odd combination of ex and e to negative x arise frequently in math and calculus, so they deserve to be given special names. So they did that. They just like the trig functions, they call them the hyperbolic functions. So you have hyperbolic sine and hyperbolic cosine. So when we read this thing, we'll keep it the same way. So we'll say hyperbolic sine of x. And you see, it's interesting how it became this ex minus e to negative x divided by 2. And same here for the hyperbolic cosine of x. It's similar formula, just it has a plus in between. And just like trig functions, you have a sine give you a cosine, and sine and cosine give you a tangent, and reciprocal, give you cosecant, and reciprocal give you secant, and reciprocal of tangent give you cotangent. So similar idea here applies. The hyperbolic tangent or tan of x, it can come from the ratio, just like you've done in trigonometry, sine of x over cosine of x, from trigonometry. So similarly, right? And here for us, it's just to know what they are and how to use in some calculations, and that's all. We'll look into derivative, but we won't dive in anything other than just the simple ideas for this 311 section. And they have their identities, and you can compare to the trig functions and so forth. And so let's look at an example. Prove that this hyperbolic cosine minus squared minus hyperbolic sine squared equal 1. And so we can replace with each one. The cosine has a plus and this one has a minus. And we can, of course, square the denominator, but FOIL the others and get 1. It's not something we'll work more on, but I'll do the examples, but you can try it. Similarly for B, you can just follow with the notes. That's not a big thing, but I will do some examples here when it comes to, for the homework. The derivative of the hyperbolic functions. Similarly, here is these formulas that you can follow, right? And now you know what each one is. And of course, an example here that you see a chain rule applies, right? Similarly, you have a function and you have an inside function. So the derivative of the outside of the hyperbolic cosine with the input of the inner part times the derivative of the inner part. Then the inverse hyperbolic functions, just like with the trig, y, the inverse hyperbolic sine of x equal y. What it means the sine of y, so you switch on this. That means the hyperbolic sine of y equal x. So just like the trig function definition and the inverse trig function definition. And of course, some would require some domain If you're asked to find to calculate something for the inverse hyperbolic, you can use directly these formulas with the logs. So we can see. I'll go ahead and work on give you these for the notes if you want to follow them and their derivatives and the formulas. I'll go ahead and solve the homework problems, and you can follow them for your examples. And if somebody's interested more, they have the notes now. So number one, for example, what is the hyperbolic sign for 0? Of course, we're going to follow the formula that we had. Right, so we'll just follow the formulas that were given. Right, so these for that one. And of course, 0 and -0 is going to be the same. So 1/2 times 0, which is 0. Let's say we're asked for cosine hyperbolic of 0 to see the difference. And that's 1 plus 1. Right, so 1. Question 2, for example, you're asked to find the hyperbolic tangent of 0. So now that we know the sine hyperbolic divide, so we can put this over there, so we can, just follow the same way, just like we did in trigonometry. So we know the answer for this one, we know the answer for this one, so it's 0. You can as well do for 1, right, and follow the same thing. If this formula here, of course, if you want to simplify it, you can. So if we go here, the hyperbolic, if you want to do this, just divide by 2, divide by ex plus e. That tells us to keep the first one. Times 2 divided by, and this cancels. So this formula simplifies to this. So if you want, instead having to come up with it, you can use it for tangent hyperbolic all the time. So it's not the formula that changes. So for example, what is the hyperbolic tangent of 1? If we want to use that formula, we'll do E1, E -1, divided by E1 plus E -1. So we can do, this is E plus 1 over E, and this is E plus 1, that one is minus, and this one is, we can remove this one here because it's the same thing. So of course now we can find the common denominator to combine to make them a single fraction, or you can multiply up and down by E to simplify this thing. So these are some of the skills that everyone needs to know. So that's will be 1 and 1 squared, cancel, 1 and 1 squared, cancel. And you can do this on a calculator, of course, and find like 0.7615 and a few other numbers. What else? Let's say we're asked to find, this is question 3. So uh, hyperbolic cosine of, let's say, ln 5. So here we'll combine use the logarithmic properties. So first we'll substitute h1 in the formula. Then this simplifies. The natural log is the inverse of the exponential functions, so they cancel each other and they give you 5. And this one we can make it the same. You know that property there of the power rule for the exponent, so you can become an exponent. All right, so which is not this way, 5 negative 1. All right, so 1/2, 5 plus e, so ln 1/5. And now these, they cancel and they give you 1/2, 5 plus 1/5. And that should give us 13/5. And we can use a calculator and get like 2.6 some numbers there. Let's say we need to calculate hyperbolic secant 0. This is a reciprocal function of the hyperbolic cosine, right? Which comes up to be 1 and 1. So you can calculate and see it, right? And we already did that, so. The inverse, let's say you need the arc cosine h1, so which means the hyperbolic inverse cosine. Well, that's going to be 0. Why? Because when we did cosine hyperbolic of 0, we found 1. So based on the inverse definition, that means this is 0. Number 5, for example, if you need to calculate for, let's say, number 1. Well, you're just going to use the formula again. You're going to say, well, I know that this is ln of x plus square root of x squared plus 1. And so saying that that's going to be ln of 1 plus 1 squared plus 1, 1 plus square root of 2. And if we need some calculation, we can get some number like that. All right. So these are not, of course, the difficulty is going to be to memorize all this, but we don't have to memorize them here. We just need first to recognize them, understand them, and if somebody is interested, they can also look into the book or other notes, but we're looking into their basic operations in this case. So sometimes just to prove, like you have in the notes to prove something, but let's look at the simple one. We can prove that this is actually it's same as this, you know, when and that's kind of an even property we say even function or even property. When it happens, f of negative x equal f of x. So let's see, is this, we start with the left side. We apply these in the formula. The other one comes with minus, so minus negative x. And that's a positive. That's exactly same as this. Or the other formula that is written on top. Either way, that's same thing. So yes, that's the hyperbolic cosine of x. That's all. Thank you.